This was kind of a trick question because all of the listed answers are ways a transaction can leave the memory pool. Let's recap the possible situations. First, if a transaction has been sitting in the mempool for too long, at the time of this recording, 14 days, it will be removed. In the next possibility, assume all transactions are sorted by fee size with the lowest transaction fee at the bottom. If the memory pool reaches its size limit and a new higher transaction fee is accepted into the memory pool, the transaction with the lowest fee is pushed out of the memory pool. So this answer choice discusses a concept we didn't cover just yet: fees. Confirming Bitcoin transactions requires a lot of computational energy. That means a lot of electricity bills to pay. Every time a sender puts out a transaction, they can add on a transaction fee. Think of this as a tip for the miner. Not all transactions come with identical transaction fees. Miners can look through all possible transactions in the memory pool to see which ones have transaction fees and look at their values. Miners, like most people, like being paid, so they'll choose to validate transactions with higher fees. But let's circle back to the question. If the memory pool was reaching its max size limit and a new transaction entered that had a higher transaction fee, then the transaction with the lower transaction fee would be deprioritized and squeezed out. The third choice, that the transaction was included in the block, is one that we discussed earlier. Now, the reasons transactions wait in the memory pool in the first place is in hopes of being validated. Then they can leave and permanently be added to the blockchain. And finally, the last answer choice. The transaction or one of its unconfirmed ancestors might conflict with a transaction that was already included in a block. Remember that the blockchain keeps a permanent history of transactions. Once a transaction is included in a block, it's considered to have one confirmation. As soon as another block is mined on the same blockchain, the transaction has two confirmations. The transaction continues to get more confirmations as more blocks are mined on that same blockchain. 6 or more confirmations is considered sufficient proof that a transaction cannot be reversed. So there's a 99.9% confidence rating that there's no errors with the transaction that have been added to the blockchain. This means that if the transaction in question conflicts with what's already on the blockchain, chances are there's something wrong with it, and that transaction will be denied and have to leave the memory pool. Now we know some of the ways a transaction could leave the mempool, but it's important to know that transactions that have left are always welcome back. For example, when they're part of the local wallet and get rebroadcast, or when they are received again over the network. Eviction does not imply a transaction is canceled. There is still hope. In this concept, we learned about the importance of the memory pool. From there, miners will bundle up transactions into blocks that will be added into the blockchain. We also saw that there are reasons that a transaction might leave the mempool, but not make it into the blockchain. Perhaps the transaction is invalid, or maybe it's timed out. Well, the mempool is a temporary place to check our work before sending it permanently into the blockchain. Now, the purpose of this holding pool is to provide transaction security. Once a transaction is included in a block, and that block has been confirmed 6 times, meaning 5 additional blocks have been added to that same chain, that block is considered irrevocable, as it will require an immense amount of computation to validate and recalculate those 6 blocks. As with many aspects we've discussed before, because the purpose of the blockchain is to exist as a transparent, immutable source of truth, the information on it is not checked once, twice, or 3 times, but 6 times to ensure security.